Hello there and welcome to SNMB Academy. Today we'll be looking at angles on parallel lines. So first we actually need to understand what parallel lines are. These are lines that will never ever meet together. So let's say if I have two lines, okay, and they are identified using these arrows. So these arrows suggest that these are parallel lines. Sometimes they even have two arrows like these. So this suggests that these are parallel lines. Now these two lines will never ever meet together. They have swore an oath that line will go its own way, this line will go its own way. They will never ever cross one another's path. So what we can actually do is that we can have angles amongst these two parallel lines. Now let's say that if I have a line in the middle cutting through like this, okay, now what we need to see is that every single area here, this is an angle, that's 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 an angle, this, these are all angles. So let's say if we're looking at this, let's just label that as angle A. This angle A would be identical, exactly the same as this angle. And why is that? The reason being is because these two lines are parallel. And there's only one line that's cutting through both these parallel lines, which makes this exactly the same as this angle. So easily there's another way to easily identify them is you can have a look that this will make a perfectly shaped F. So you can actually also call them the F angles. Okay, but the correct mathematical term for them to know would be the corresponding angles. So corresponding angles are always the same. In this case, the F shape, the F angles. Okay, now let's say we have let me just show exact parallel lines again. So we have the arrows to suggest that these are parallel lines. Let's cut the line through the middle. Now, like I already suggested to you before, that these are all angles. So we've already tested these. So let's just take this angle right now. So let's just call that angle as angle B. So this angle would be exactly the same as this angle. And we can easily identify them by labeling them as a Z. So this Z angles. You see? However, the correct mathematical term for both of these, for this angle, would be the alternate angles. Alternate angles. And the reason being for that is we have parallel lines again. We got a line cutting through the middle. So we got two parallel lines, one here and one here. And a line is connecting both these parallel lines together. So angle on one end and the angle on the other end will be exactly the same. Therefore, we call these the alternate angles. And moving on from there, we can have the, let's say, X angles. So let's just call this angle over here C. So this angle would also be C because they are completely opposite. So whatever angle this one, whatever degrees this angle would be, this one will be identically the same. So we can call these the X angles. But the correct mathematical way of this would be the opposite angles. And opposite angles are always the same. So if we want to say that this angle would be D, so this angle over here is completely opposite this, so that will also be identically the same as D. So there we have it, three different type of angles, just easy to understand. But these all three angles that I've just shown you, three different types, can easily be merged into one. But I've just separated them into three different ones so you can easily identify as to how exactly each one of them looks like. So let's just practice a question underneath. I've got a question underneath here. Okay, so this question is asking us to find the angle. So find X. Okay, so first what we need to see is we can easily see that it's creating a wonderfully shaped F. So we can get an F angle, we can get a Z angle. Okay, so like I was telling you before, so the question will always merge all the angles together. So let's just say we look into the F angles. Okay, so we know that this angle over here, 113, will be exactly the same as this angle, 113. Okay, so we can say that, let's just say this angle as angle, I don't know, F. Okay, so we can say the angle F is 113 degrees. And what's the reason for that? Is that this is corresponding angles. Okay, reasons are important so we know exactly what we're talking about and why some angle is what it is. And to find x, now we know that angles on a straight line, as you can see, it's a straight line, are equal to 180 degrees. So if this is 113 degrees, to find x, it would be 180 degrees take away 113 degrees, which will result in 67 degrees. So x becomes 67 degrees. It's literally as straightforward as that. So let's just try another one. Now this question, a lot of students, get this confused. They completely just look at the angle straight away. They look at the shape and they think that y will be 62 degrees because y is looking identically same as this. But they forgot to read this part. Diagram not accurately drawn. We do not let the shape defy our eyes. Okay, we need to understand the mathematical rules that it's not what it is, whatever we see. So in this case, we can have perfectly Z angle, okay, in which we know that this angle will be exactly the same as this angle. Why? Because that is the alternate angle. Therefore, my angle Y will be 64 degrees, not 62 degrees. So it's as simple as that. We just wait a minute, look at the question, look at what shape you can form, click back our rules that we've just done at the start of the video over here, and try to click back and apply these, three angles inside the question.